All right, so let's take a look at problems 3 and 4 now. And I'm just going to give away the ending to one of these problems, sort of, which is that problem 3 cannot be done right now. So we're going to get back to that one later. Now, we'll move on to problem number 4. So we have a bus moving at 20 meters per second. So that's our initial velocity. Now, this confused some people in class, so let's be very clear on this now. It says, slows at a rate of 4 meters per second each second. It didn't say goes at a rate. It says slows at a rate. So this number has to do with slowing down. And that tells us it's an acceleration, and we're going to actually use a negative sign when we put it in the formula. So for part A, let's actually, and I'll just make absolute sure they have all this. Okay, so part A, it says how long does it take the bus to stop? If it's stopping, that means V final is 0. So let's go ahead and plug in our number. So we have 0 equals 4t plus V naught, which is 20. And that's a negative 4 because it's slowing down. And so what we end up getting when we do this is t is 5 seconds. So if you didn't follow that, stop the video and do the algebra. It's very important that you sort of start getting used to that because we have a lot to cover this year. Now, the next question we have is how far does it travel while braking? So let's go ahead and set up our graph. So we start at a velocity of 20, so that's V naught. And then we brake like this. And we do that at 5 seconds. So now let's go ahead and get the distance it travels by using our area formula. So that's area equals 1/2 base times height. That's going to be 1/2 times 5 seconds times 20. So this is the height's 20, and this is the base. When we actually calculate that, we're going to end up getting 50 meters is our displacement. So that's it for number 4. Okay. Now, we're going to move to number 5. Or not. All right. So problem number 5 is going to be just like the other problems that we're doing. So let's just go ahead and get the solution. I think what happened in class is that people got confused by this idea of downhill and this idea of what is the length of the slope. And I saw people do this thing where they would draw the graph here, and they'd say, oh, this must be the slope. No. No, no, no. That is not anything at all what this problem is about. Okay? It doesn't work like that. What we really mean to say is what is the length of the hill, and this is a very fancy way of saying get the displacement. And you need to get used to this kind of language because here's what's going to happen on a physics exam. They will not actually hold your hand and tell you, would you please calculate the area under the curve and call that the displacement and you'll get 100%. It doesn't work like that. That will never happen. Just let go of that fantasy that's going to happen. It will always be phrased in some confusing fashion like this. You need to get used to that, especially for college. So here's the deal. This is the acceleration A. This is the time t. And we start skiing down a hill. So we start from rest. So now let's set up our equation. We have V equals AT plus V naught. And we're going to say that this unknown V is going to be 2 times our time, which is 15 seconds, plus our V initial, which is 0. So we get that our V at the bottom of the hill is 30 meters per second. And it's very tempting to say, we solved the question, but we haven't. They want to know the length of the slope. So now let's go graph this. So we have 30 up here and 15 here, and we plot our line. So our equation would be V equals 2t. So we plot like that, all the way up to 30. Now, to get the length of the slope, we actually need to do that by getting the displacement. So let's go ahead and do that now. So my height is 30, and my base is 15. So my displacement is is going to be the area of this triangle, which is 1/2 base times height, which is going to be 1/2 times 15 times 30. So that's going to be 15 times 15, which, if I'm not mistaken, is going to be 225 meters. All right, excellent. Now question number 6. We move on. We have a dog running around his driveway with an initial speed of 5 meters per second for 8 seconds. Then increases the speed to 10 meters per second in 5 seconds. What is the acceleration in the second part of the motion? How long is the driveway? So let's go. So first of all, let's get his acceleration during the second part of the motion. So part A, we have this initial speed of 5 meters per second, and then we have a V final of 10, and this is the time. So there we go. We have V equals AT plus V naught. And to get the acceleration, we're just going to say that 10 equals A times 5 plus the 5 that we start at. So A ends up being 1 meters per second squared. Excellent. Now we want to know how long the driveway is. Let's do this calculation. So we are here at 5 meters per second, and we go all the way up to 10. How does that happen? Well, for the first 8 seconds, we're here. And then for another 5 seconds, out to 13, our velocity increases to 10, like that. And there we go. So we actually have to get the area of this whole monstrosity right here. So we have this whole rectangle and this whole triangle here. So we have 13, and we have a height of 5, so the area is going to be the rectangle plus the triangle. So the rectangle is going to be 13, that's the base, times the height, which is 5, or length times width. And then the triangle is going to be 1/2, so we go from, let's get the height. The height here is 5. And we have an additional 5 here, so this is going to be 65 plus 12.5. So what we end up getting for part B is, or rather for part B, we end up getting 77.5 meters. Right. So that's that. Now for question number 7, this is going to be another star. We're going to do this in our last video. And so now we're going to go ahead and do this very last question here. So here we go. Initial speed, final speed, time. Let's get the acceleration. Okay, so V equals AT plus V naught, and we have here 10 equals A times 5 plus 30. And my acceleration, when I solve this, ends up being -4 meters per second squared. There we go. Now this is going to be pretty interesting. So let's go ahead and actually try to get this number here. This is going to be quite a tricky problem because my graph looks like this. I go from 30 to 10, like this. And so I have 1, 2, 3, 4, 5. Okay? Now what I want to do is calculate the area of this part right here. Right? That is going to be a tricky problem, and I'm going to draw a big frowny face right here. What I'm going to challenge you to do is, instead of using the area for a tricky question like this, what we're going to do instead is, when we come to class and I see you guys next time, we're going to take up this problem in class, and we're actually going to have you solve it using the equations that we'll be looking at in the third video. Right? V naught squared plus 2a delta x, v final equals at plus v naught. So that's going to be kind of what we do in our next video. We're going to do the 2 star problems, and that'll be it for today's videos.